Suzie. My background is in environmental chemistry, and I hail from the Indian River Lagoon Estuary in Florida, where I worked for several years doing monitoring on large-scale stormwater projects. I did the monitoring to see if they were working or not, and if the pollution reductions were equaling what we thought we were going to see from the models. So going back to school, I wanted to keep going along the same vein, but switch my focus to trying to see if we could quantify how community projects can affect water quality. So I'm going to talk to you today about my dissertation project, where I'm looking to see how water conservation during storm events could have a measurable effect on the pollution that's coming out during these combined sewage overflows. So not to beat you guys over the head with the basics, but here's a quick schematic of how a CSO works. We have here on the left normal conditions, all of the sewage from our buildings and apartments and industries are going to the wastewater treatment center like they're supposed to. Then, since we have a combined system, when we have heavy rains, we have a lot of extra water coming in from the storm drains. And that overwhelms the system, the water goes over the weir and out untreated into our local water bodies. This is associated with a lot of pollution. This is a short list here. So we have bacteria, pathogens, viruses can be associated with this. We have toxic heavy metals, oils, gasolines. We also can have excess nutrients, nitrogen and phosphorus, and also excess suspended solids, which can cause ecological problems in addition to the public health threats. Here's a quick map I made of all of the CSOs in New York City. As you can see, basically the whole shoreline is dotted with them, especially along the East River. And thinking about how I would focus my dissertation project, we're seeing that this is a mixture of stormwater and sewage. And a lot of the effort is going to the stormwater portion of this. It's easy to attack. I wanted to try and think of something that regular citizens could do. So having a meeting one day with Bart Chazar, who's here in the room, we started to think, well, what about the sewage portion of this? What if people use less water during the storms? Could that have a measurable impact? So I decided to investigate that. Turns out that a lot of the water used in the city is residential, and I was actually surprised by how much. About 77% of the water that we can account for that's used in the city is for residential purposes. So it makes sense then that when we have an overflow of sewage mixed with stormwater, that a lot of that is coming from residents. So the way that someone could participate in something like this would be while it's raining and for a period of time after. The timing of that, as Katie said, is a little hard to monitor right now. But what they could do is use less water around the house for dishes, laundry, flushing toilets, taking showers, anything that people are using water for around their house. So to investigate this, I decided to do a pilot study in my watershed, which is the Gowanus Canal. Here's a map of this sewer shed for those of you that may not be familiar. The Gowanus Canal is about 1.8 miles long in Brooklyn, and it has 10 combined sewage overflows. And this is in addition to all of the historic pollution that is causing it to be a Superfund site right now. So you can push the next one. So the first step of what I wanted to do is do some computer modeling to see, all right, if we have less water use during a rain event, what would happen to water quality, at least in terms of a model. So I did this monitoring for this small sub-sewer shed here, which is actually the biggest one in the Gowanus Canal. It's where most of the combined sewage overflow is, it accounts for most of the volume of the combined sewage overflows. So how I did the modeling is I simulated several storm events, and every time I just lowered the amount of water coming in. So we have the water coming in from stormwater, we have the water coming in from sewage. I ran the storm events as if everyone was doing everything as normal, and then I lowered it by 5%. So I said, okay, everyone's using 5% less water, now 10%, and so on, all the way up to 50% less water. So here we have on the bottom the amount of water use reduction. And I wanted to see what would happen in terms of total flow to the outfall point, and also the total amounts of different pollutants that we're concerned about. So here's a graph for flow, and, oh, sorry, think of that. We can see that as the water use reduction goes up, that we can start to see some reduction in flow, starting at about 10% less water use. And at 50% less water use, the flow reduction goes up to about 15%, which isn't huge, but it's something. And also, in a way that this is different from what would happen when we're targeting stormwater, is that the sewage portion, which this would be targeting, is a more concentrated source of pollutions. So if you see, the pollution reductions are a lot bigger because what we're taking out is a more concentrated source. So here I've graphed some of the target pollutants, which are total suspended solids, copper, zinc, lead, which are heavy metals, and fecal coliform. And they're removed at about twice the level we see for flow because they're more concentrated. And we can see they're removed from about 10 up to almost 35%. And these numbers are pretty comparable with small to medium scale green infrastructure projects. And this is something that would be free for people to participate in. But of course, the huge question, would be, this would completely be contingent on people actually using less water during a rain event. Which, in the model, I just removed the sewage, and it was easy to see that, yes, the flow will go down, and yes, we'll see the smaller pollutant loads, but I need to see if there was any way that people would actually try doing something like this. So I did a very simple community survey in the Gowanus Canal area about which the whole sewer shed that I showed there, and I basically figured out how likely people were to conserve water during a storm event overall. You can click. How likely they were to reduce their water use for specific activities. So it seems pretty obvious people might be way more willing to put off doing their dishes or their laundry than they are to not flush their toilet during a storm event. So I had to ask about that. And I also had to ask about how long they would be willing to conserve water. So maybe if we're having an intense summer storm in July and it's going to be an hour or so, sure, people would do that. But if it's going to be a rainy day in April where it's going to be raining all day, forget it. So I just wanted to see what would people even say about this. So I'm still waiting on a few of my surveys, but I have enough that I can share some results with you today. I asked people to scale what they would do on a scale of 1 to 5. 1 being, no way, I'm never doing that, and 5 being, yes, please sign me up. So on overall, so asked, overall, how likely would you be to use less water during a storm event? The average answer was 3.6 out of 5, which is pretty encouraging. That's on the probably side of things. And we can see down here, response by time is pretty much what we expected. If we have a smaller storm, 1 to 2 hours, most people said, yeah, I'd probably do that. And as we get past 6 hours, people are starting to say, maybe not. And I didn't pull out all of the behaviors here, but the one that I was most interested in, because this is where a lot of the pollution is coming from, is what do people say about flushing their toilets during a storm event? And the average answer here was 2.4 out of 5, which is almost squarely on maybe. And I'm going to call that positive because I was honestly expecting that to be a flat out no, and it wasn't. So this is telling me that, at least in the Gowanus area, there's some real interest in people actually participating in this. And I have a few other stats I'd like to point out, which lead me to believe there's also a strong educational component here. From the people I surveyed, 65% of them said that they were concerned about CSOs. 66% of people were not sewer shed aware, which is a term that I totally made up, to indicate whether I asked the question, prior to this survey, did you know that the sewage from your apartment drains to the Gowanus Canal during a rain event? 66% of the people said no, which was not too surprising, but I thought that it was interesting because it's a very comparable number to the people that are concerned. This last percentage here, 38% of the people said, yes, I'm concerned about CSOs, and no, I didn't know that I was contributing to one. So I found that very interesting and indicative of an educational component there that I'd like to explore a little more. I think it's interesting that people do seem to be concerned, didn't seem to know, and a lot of people's questions, even those that said they weren't very concerned about CSOs to begin with, once they got to the point in the survey where they were informed that they were contributing to one, their answers changed to indicate that yes, they would now care and they would now participate in a program to try and lower the pollution. So next steps for me are to improve the model. I'd like to get the most accurate pollution loading data that I possibly can. I need to finish collecting my community survey data, and what I'd like to do is feed that back into the model. To make the models as realistic as possible, I want to reflect what people say they'll actually do. So what percentage of people say that they would use less water, and how would they use less water? How long could they use less water? And try and compare this to the types of storms we're seeing to try and get a realistic idea of what the quantitative impact that we could expect to see in our local waters would be. And I'd also like to explore a little bit more about how simple education could impact people's willingness to participate or not in a program like this. Thank you.